In today's video, we're going to learn about how to find the area of a surface of revolution. So first thing we need to know is what is the surface of revolution. So that's when you take a continuous function and you evolve it about a line. The resulting surface is what we call the surface of revolution. So we're going to find the area of that surface. To do that, basically what we're going to do is we're going to find the length of the surface using arc length, and we're going to use that arc length into our formula. First thing you have to do is you got to look at the area of the surface S, which is big S, of the surface of revolution formed by revolving the graph of F about either the horizontal axis or a vertical axis. So we're either going to be horizontally or vertically. So you got to figure out which one it is. If it's horizontal, our formula is going to be 2 pi, the integral from a to b of r sub x times by the square root of 1 plus our f of x derivative squared dx. So basically, radius, the distance the segment is from your axis of revolution, times by the arc length. So that's basically what we're looking at. Our surface area is going to be 2 pi times the integral from a to b of the radius times the arc length of dx. Where r sub y and r sub x is the distance between the graph of f and the axis of revolution. So that's what we need to figure out. So we have to figure out the distance between our graph and the axis of revolution. So let's look at an example. We want to find the area of the surface found by revolving the graph of f of x, which is equal to x cubed, on the interval from 0 to 1 about the x-axis. So first, sketch a graph. So here is our x cubed graph. So we're only looking from here, that's where x equals 1. So we're looking from 0 to 1. And we're going to take this and we're going to revolve it around the x-axis. So our axis is a horizontal axis. So we're going to be in terms of x. So first thing I got to do is figure out the distance that this graph is from the graph of x cubed is from our axis of revolution. So that's going to be our r of x. So we have 2 pi, the integral from 0 to 1. Now we got to figure out r of x. Well, r of x is just our function, because our distance is straight our function. So that's going to be x cubed. And then we're going to times this by the arc lengths. So to do arc length, I need to know the derivative of x cubed. So the derivative of x cubed is simply 3x squared. So I'm going to have 1 plus the 3x squared, quantity squared, dx. And that's it. That's how you find the area of a surface of revolution. So now it's just using some calculus. So I'm going to simplify what's underneath the square root. And then I notice I have x to the 4 times the square root and x cubed outside the square root. So I think I could use this by solving using u substitution. So we're going to let our u equal what's inside the radical. And the derivative of this is going to be equal to 36 x cubed dx. And solving that for dx, I get dx is equal to du divided by 36 x cubed. And so we can now turn this, and in order to turn this in terms of u, I need to find my upper and lower bound. So my upper bound is going to be 10, and my lower bound is going to be 1. So I'm going to have my surface area is going to be equal to 2 pi times the integral from 1 to 10 of x cubed times u to the 1/2, and replace that dx with du over 36x cubed. So my x cubes can cancel out. My 2 over 36 can simplify to 1 over 18. I'm going to bring that out. Let's see, I forgot to bring out the 36. So I'll rewrite that as just pi over 18. Now I'm just going to integrate u to the 1/2, which we know to be 2/3 u to the 3/2. And we're going to evaluate this from 0 to 10. Let's go ahead and factor out that 2/3. So I can just have that 10 to the 3/2 minus 1 to the 3/2, which is simply 1. Well, 10 to the 3/2, that doesn't simplify down too neatly. So this would be my answer, or I could plug it in my calculator and get 3.563 as the result. Okay, I want you to find the area of the surface of revolving the graph of x squared on the interval from 0 to the square root of 2 about the y-axis. So this time we're revolving about the y-axis. So start by sketching your graph so you know what's going on and identify your axis which you're revolving around. Okay, and here is where our, when x is square root of 2, we have a y value of 2. So this is going to be that point here. Not doing a very good job doing this. So that should have been labeled the point square root of 2 comma 2. And so we're going to revolve this around the y-axis. So what we need to do is we need to figure out our distance our graph is from the y-axis, which is just a distance of x. You know, whatever our x value is for our graph there. And so then we need to, for our arc length formula, we need to figure out our function. So f of x's function is x squared. And so the derivative of x squared is simply 2x. So I rewrite this as the integral, surface area is equal to 2 pi, the integral from 0 to square root of 2 of x plus the square root of 1 plus 2x quantity squared dx. All right, so now let's simplify this down. Well, we know that 2x quantity squared is the same as 4x squared. And then I'm going to use u sub again. So I'm going to let u equal my inside function. So it's going to be 1 plus 4x squared. And so du is going to be equal to 8x dx, which means that dx can be replaced with du divided by 8x. And I need to find my new upper and lower bound. So u of the square root of 2 is equal to 1 plus 4, the square root of 2 squared. The square root of 2 squared is squared. 4 times 2 is 8. 8 plus 1 equals 9. Now to find our lower bound, replace every x with 0 and solve that, and we end up with just 1. So now we have s is equal to 2 pi, the integral from 1 to 9 of x times u to the 1/2 times du over 8x. Okay, the x's cancel out, and I can bring the 8 outside of the integral, and 2/8 simplifies down to 1/4. So I can rewrite this as pi over 4, the integral from 1 to 9 of u to the 1/2 du. And then simplify, evaluating my integral, we get that the integral of u to the 1/2 is 2/3 u to the 3/2. And then we plug in 9 and evaluate it at 1. Simplifying this down, we end up that our arc length is 27 pi over 6, which will simplify down even farther. Okay, so 9 to the 3/2 is 27 minus 1 to the 3/2 is 1. 27 minus 1 is 26. So that gives us 26 pi over 6, which will simplify down to 13 pi over 6. So the area of the surface revolution formed by revolving this line about the y-axis is 13 pi over 3.